divergence of a vector function the divergence of a vector point function capital F is denoted by divergence F and is defined as below. Let vector F can be written as F1i, F2j, F3j. Then divergence vector F is equal to del dot F is equal to I del upon del x, j del upon del y, k del upon del z. I F1 j F2 k F3. So I dot I 1, j dot j 1, k dot k 1, and I dot j 0, j dot I 0, k dot I 0, k dot j 0, and I dot k 0, j dot k 0. Then del f upon del x, del f2 upon del y, del f3 upon del z. So divergence of f is a scalar function. Okay, now physical interpretation of divergence. Okay. X, Y, Z plane, and this is origin. A, B, C, D, P, Q, R, S, and this is del Z. Here V, X, and this one. So let us consider the case of fluid flow. Consider a small rectangular parallelepiped of dimension dx dy dz parallel to x y z axis respectively. Okay, let vector v can be written as vxi vyj vzk. V the velocity of fluid. At a point P, which is x, y, z. Now, mass of the fluid moving flowing into the phase A B C D in unit time which is equal to velocity into area of phase. Which is equal to Vx dy dz. Okay, now mass of the fluid flowing out across the phase, mass of the fluid flowing out across the phase PQRS per unit time equal to Vx x plus dx. Okay, Vx x plus dx dy dz, which is equal to Vx plus del Vx on del x dx dy dz. So net decrease in mass of fluid in parallelepiped corresponding to the flow along x-axis per unit time. Okay, so which is equal to Vx dy dz minus Vx plus del V upon del x dx with dy dz. So we can write as minus del Vx with respect to del x dx dy dz. Here the minus sign, so the decrement. Similarly, The decrease in mass of fluid to the flow along y-axis equal to del v upon del y dx dy dz, and the decrease in mass of the fluid to the flow along z-axis is equal to del v z upon del z dx dy dz. Okay, so here we have total decrease of the amount. Okay, total decrease of the amount of fluid per unit time which is equal to del v upon del x del vy upon del y del vz upon del z with dx dy dz. Okay, thus the rate of loss of fluid per unit volume which is equal to del vx upon del x del vy upon del y del vz upon del z. So which is equal to I del upon del x j del upon del y k del upon del z dot I vx j vy k vz. Okay, here the del and this is a vector v which is equal to divergence v. If the fluid is compressible, there can be no change. Okay, there can be no gain or loss in the volume element. Hence divergence v becomes 0, and vector v is called solenoidal vector function. And equation 1 is also called the equation of continuity. Okay, Okay, the next question is, if u is equal to x square plus y square plus z square and vector r is equal to xi yj zk, then find divergence ur in terms of u. So solution is, divergence ur which is equal to I del upon del x j del upon del y k del upon del z dot u means x square y square z square into, and vector r means xi y j plus z k. Okay, so I del upon del x j del upon del y k del upon del z. Here this x square y square z square into xi x square y square z square into yj and x square y square z square into zk. Okay, so I dot I1, I dot j and k become zeros. That means this term is differentiated by x only partially. Del upon del x cube plus xy square plus xz square del upon del y means x square y plus y cube plus z square y. Okay, and del upon del z means x square z plus y square z plus z cube. Okay, now differentiating partially with respect to x, then we get 3x square plus y square plus z square, and here we differentiate partially with respect to y, then we get x square plus 3y square plus z square, and here we differentiate with respect to z partially, then we get x square plus y square plus 3z square. Okay, so 3x square x square x square, that means 5x square, y square 3y square 4y square and 5y square, z square 2z square plus 3z square, that means 5z square, that means 5 times x square y square z square, which is the value of u. Okay, that means 5u, which is the required answer. Okay, next question is, find the value of n. Find the value of n for which the vector r power n vector r is solenoidal and where vector r is equal to xi plus yj plus zk. ठीक है. The definition of the solenoidal means divergence of this vector is 0. So divergence of f. So divergence of r and r vector, which is equal to divergence of r vector power n means x square plus y square plus z square power n by 2. Okay, and vector r means xi plus yj plus zk. So del means I del upon del x plus j del upon del y plus k del upon del z, and this means x square plus y square plus z square power n by 2 into xi. Okay, plus x square plus y square plus z square power n by 2 into yj plus x square plus y square plus z square power n by 2 into zk. Okay, so I dot I1, j dot j1 and k dot k1. So we get del upon del x square y square z square power n by 2 into x plus del upon del y x square y square z square power n by 2 into y del upon del z x square y square z square power n by 2 k and z. Okay, here we can differentiate partially with respect to x, and here we differentiate partially with respect to y and others term as x and z be a constant, and here we differentiate partially with respect to z only. Okay, so differentiate x only with respect to x, and y and z treat as a constant. Clear? So we get n by 2 x square y square z square and power n by 2 minus 1, and here 2x square plus x square y square z square power n by 2. So differentiate with respect to y only partially, then we get n upon 2 x square y square plus z square power n by 2 minus 1 into 2y square. Okay, plus x square y square plus z square and power n by 2. Okay, and this term we differentiate z only partially, then we get n by 2 x square y square z square power ny2 minus 1 into 2z square plus x square y square z square power ny2. Okay, so solving this term, then we get cancel out this term and this term. Okay, so n times x square y square z square and power ny2 minus 1 and x square, this term and this term, n x square y square z square power ny2 minus 1 z square and this term plus n x square y square z square power ny2 minus 1 into y square. These three terms plus x square plus y square plus z square power ny2 x square y square z square power ny2 plus x square y square z square power ny2 plus x square y square z square power ny2. Here common n and x square y square z square power ny2 minus 1, this and this term. Okay, then we get x square y square z square power ny2 minus 1, then we get x square y square z square and 1 2 3 times x square y square z square and y 2 times. Okay, this term will be added in this term, then we get x square plus y square plus z square power ny2 plus 3 times x square y square z square power ny2. Okay, and now taking this term as a common, so x square y square z square power ny2, taking common term, then we get n plus 3. Okay, for solenoidal vector this term become 0. It means if r vector r is solenoidal, then del dot r and vector r become 0. So x square plus y square plus z square power ny2 into n plus 3 is equal to 0. This is never be 0, then n plus 3 equal to 0, or x square y square z square power ny2 is equal to 0. Okay, so this term will not be equal to 0, then n plus 3 is equal to 0, then n is equal to minus 3. That means the value of n is minus 3 for r vector r and vector r is solenoidal. Okay, now Again I repeat the question. Find the value of n for which the vector this one is solenoidal and the vector are defined as xi plus yj plus zk. Okay, for solenoidal vector we have this term v is 0, so we have calculated divergence v. ठीक है, v means this one, divergence this vector. Okay, del dot vector r की power n means x square plus y square plus z square whole power n by 2, and vector r means xi plus yj plus zk. Okay, the value of del is I del y del x plus j del y plus k del y del z. Okay, and here this term is multiplied by I, this term multiplied by this term, and this term is also multiplied by this term. Then we get this I plus x square plus y square plus z square whole power n by 2 yj. Okay, plus x square plus y square plus z square whole power n by 2 zk. Okay, now here I dot I1, so we get del y del x square plus y square plus z square n by 2 into x, and j dot j is 1, that means del y del upon del y x square y square z square whole power n by 2 into y, and del y del z is x square plus y square plus z square power n by 2 into z. Okay, so differentiating with respect to x, then we get this term. Differentiating with respect to y partially, then we get this term, and differentiating with respect to z partially, then we get this term. After solving this term, cancel out 2 and 2. Okay, so this term plus this term right here, and this term plus this term and this term right here. Okay, the common taking x square plus y square plus z square whole power n by 2 minus 1 with n, this term with this term and this term, then we get n x square plus y square plus z square whole power n by 2 minus 1, and remaining term x square plus y square plus z square, and further x square plus y square plus z square whole power n by 2, this term same this term with this term, यानी कि 3 times x square plus y square plus z square whole power n by 2. Okay, now in the multiply power will be add, so minus 1 plus 1, that means n by 2 only, so n x square plus y square plus z square whole power n by 2 plus 3 times x square plus y square plus z square whole power n by 2. So common this term, then we get n plus 1. For solenoidal vector we have divergence this vector equal to 0. So this term multiple become 0, either this term equal to 0 or this term equal to 0. This is a vector quantity, so it not will be equal to 0, that means here only n plus 3 equal to 0, that means n is equal to minus 3. Okay, the value of n is equal to minus 3. Okay, check it now.